I'm going to be talking through this particular draft of problem 8 from the Proofs Projects drafts. So we're trying to prove or disprove this set relationship works or not. And so it looks like, I think, yeah, you're just talking to me, seeing what I think about some of these things, and that's okay. Just make sure in your final draft you just write to anyone, include example, maybe clarify statements. Okay. By definition of subsets, all elements of the set A must be contained in the set B. Alright, so if you're going to use A and B, I think that's a really great idea because these sets are gross to type. So, but what you want to do before you go into that is be clear what you mean by A and B. So what you could do with the start of this proof, you could say let A equals 3k plus 2, where k is an integer, and let B equal, and then for the rest of the proof you can just refer to them as A and B, and you don't have to write out this long gross thing. So I'm going to do that as I read this. So now, in order to show that some element x of, now careful with this set representation here. This integer thing here must be inside of the set, otherwise it doesn't have much meaning outside of there. So just be sure to leave it in this set notation, or even easier, use that A and B representation, as long as you declare within your proof that those sets are A and B. Okay, so we want to show that some, if I pick an element in A, it's also going to be in B. And so it looks like down here we are disproving it, and so I think it's really great to let your reader know that you're disproving it. Otherwise, they kind of get the wrong idea that this is true. So it's nice if you're doing a disprove, if you be clear right away that you're disproving it. So you could say, we will find a counterexample to disprove this relationship, or in order to show that some x is an element of A, is also an element of B, to show that that relationship isn't true, we're going to find an element in A that's not in B. That's how we would show it. So you could discuss that. So again, with the set notation here, I would just say A, or make sure that that integer part is defined within the set. Otherwise it doesn't have the same meaning outside of it. So we're saying assume x is an element of A, and then I do like it though that you're declaring this integer, because maybe you're doing it for this x here, but I'm not sure. Because if you're going to define x in this way, then you do need to say, okay, k is an integer, because now that meaning is outside of the set. We don't know what k is. We know what k is when we're in the set, but now we're outside of it. And so I'm not quite sure I follow what you're trying to do here. I think this is back from number 7, and so I think I don't think you want to include this, because where we're trying to go is write it as 2 times some integer plus 3, and so that's not quite what we want to see there. Okay, and yeah, we haven't quite proven this here. Because your conclusion here has to do with the set 3 times some integer minus 1. And we're trying to conclude something about the set 2 times some integer plus 3. Okay? Now, if we know, it's not true, okay? I can see that you're thinking about that. And I think it's a difficult switch to go from proving stuff generally to the idea of disproving something. So if we're trying to disprove a universal statement, it's really actually not that bad, because we only need one counterexample. So if we think about the definitions of subsets, so we've got all elements in our universal set. If the set A is a subset of B, we've got an element in A, then that means it must be in B. Now, if this relationship isn't true, if this is false, there must be some element of A that's not in B, okay? So that's what we're going to look for in this particular example. So we want to know, is there an element that I can write as 3 times some integer plus 2, where K is an integer, that I can't write as 2 times some integer plus 3, okay? So what we can do, oops, and I messed up this set representation here. What you can do is just list elements. So list elements here to try to get you on the path of writing out possible counterexamples. Okay, so you haven't found it yet. This isn't quite what you do within your proof. Within the proof, all you really have to say is notice something is an element of this set, but it can't be written in accordance to the properties of this set. So that's it. And so let's see, we've got, if K is -1, the first set we'll have -1, 0 is 2, 2 would be 6, 1 would be 5, 2 would be 8, and so on and so forth. Okay, now that's elements in here. Now let's look here. If I've got, let's say -2. -2 is going to be -4, -1. So that does work for -1, right? 0. -2, -1 would be 1. 0 would be 3. 1 would be 5. So it looks like there is some overlap here, right? But maybe 2 lives here, but not here. Can you prove it doesn't live here? To prove 2 doesn't live here, you'll have to show that there's no integer that makes this true. Okay, there is a real number that makes it true, definitely, right? But we're looking for an integer. Okay, so hopefully that gives you a little direction. Again, if you want to rewrite it, and then I can give you some more feedback again. Okay.